Hi students, now we are going to discuss the Raoult's law. Raoult's law for solubility of liquid, solubility of gases in liquids, gases in liquid. You must take care this one. Here, that temperature should be decreased. Generally, they are saying that temperature is increasing. No, temperature should be decreases and solubility of gases increases. You must take care of this one. And according to Dalton's law of partial pressure, total pressure of the two components is the sum of their own pressure. Whenever two gases which are chemically not combined, the total pressure is the sum of their own pressure, and P naught A denotes to the pure pressure, and wherever PA is equal to P dot A dot XE means that what is the mole fraction of that gas and pressure of pure component. It is to be multiplied, it gives you PA, and you comes to know the total pressure in this way. This gives you the pressure, total pressure, that is the mole fraction, partial pressure, and then we come to know the graphs. This whenever xa is equal to 1, of course xb becomes 0, and whenever xb is equal to 1, xa becomes 0, and they follow the straight lines. Total pressure, that is the straight line, and Raoult's law follow this graphs, that is the straight line equation mx y is equal to mx plus c. Whenever we are having the two component and they both are volatile, suppose that I'm taking here water as a solvent, then I'll take that sugar, that is also. So both are the volatile component. It will give you the both becomes come in the vapors, and the pressure into that vapor is called vapor pressure, and that is calculated. And Raoult's law is the improved form of the Henry's law. Then we will discuss that Raoult's law, total pressure, we can take two component, three component, PA plus PB, that P naught A dot XA and P naught B dot XB. And XA we can take 1 minus XB and P naught B dot XB. Then simple mathematics, common taking XB, P naught B minus P naught A plus P naught A. We can do the practice, and so many numericals we can solve here, and then come the Raoult's laws and Henry laws comparison. Raoult's law for non-volatile component. When one component will come in the gaseous form, it means that it is volatile. One component we can say that it is volatile, and another component is not volatile. Means that we will heat that and come into the gases and gives vapors, and vapor pressure can come. In this way, we will take the pressure of solution. Pressure of solution is due to the only one component, and you know that when P is equal to KHX from the Henry law, this is the value of Henry law, KH is the value of KH, and whereas in the Raoult's law, that is the directly proportional to the vapor pressure of the component in the Raoult's law. Now come PS is equal to P naught A dot XA. Simply using the maths and chemistry, PS by P naught A is equal to XA, and 1 minus PS by P naught A, it gives to you 1 minus XA. We can take this one, taking LCM and solving P naught A minus PS upon P naught A gives you XB. This is the Raoult's law for non-volatile component. Mole fraction, we can find out this is the total pressure. We can take two things from here. Whenever it will come in the form of P naught A minus PS upon P naught A, it will give you relative lowering in vapor pressure. Relative lowering in vapor pressure, and when we will take this one P naught A minus PS, that comes to you lowering in vapor pressure. These are the two typical terms. I will give you one more formula. We make the conversion P naught A minus PS. Coming next page. This is the formula for the Raoult's law. P naught A minus PS upon P naught A is equal to XB. When we are doing the sum, we have to neglect the term XB stands for NB. Here we have to neglect this term whenever the solutions are diluted. NB plus NA. This term is be neglected whenever the solutions are diluted, and we will find out the relative lowering in vapor pressure. But in this case, it is improved form, and reverse both of them and get this formula. In this formula, you have just no need to neglect any terms. Then come Raoult's law, improved form of the Henry law, and the next Raoult's law, limitations of Raoult's law. Limitations applicable on non-electrolytes. On dilute solutions only. Then we will discuss that. Thank you very much. This is the Raoult's law, important term of this chapter. Now we are coming to the next part of the Raoult's law, that is the types of solutions, ideal solution and non-ideal solution. Thank you very much for being with me.